Hey guys, in this video we are gonna see the binary search algorithm. So it is an efficient searching algorithm that works only on sorted array. So if our array is unsorted or is in jumbled order, then we cannot apply this algorithm. So the first requirement is our array should be sorted. Now instead of checking elements one by one, it repeatedly divides the search space into half. Okay, we start by comparing the target with the middle element of the array. If the target is equal with the middle, then the search ends immediately and we return the index of the middle element. But if the target is smaller, then we discard the right half of the array. Otherwise, if it is larger, we discard the left half. This process continues until the element is found or the search space becomes empty. Because we eliminate half the elements at every step, so this algorithm binary search runs in log n time complexity, making it much faster than linear search for larger data sets. So for example, in real world, if you have a very large data set and you want to search some element from it, then binary search is the best way to go, because linear search will take a lot of time and is very inefficient. Now let's take an example. We have a character array from A to I in sorted order. Okay, and the target element here is F. So we start with the entire array. The middle element here is E. Since our target F is greater than E, we eliminate the left half of the array, that is from A to E is eliminated. Now the remaining elements are F, G, H and I. Now we take the middle of the remaining part, that is G. This time F is smaller than G. So we eliminate the right half, that is G, H and I. The remaining element F, which matches our target. Okay. So the search is successful now. This is how binary search narrows down the search space efficiently and finds the target element. Okay, looks good to me. Now let's move to the code. I have created a function static int binary search which accepts an integer array and a target element. Okay, so let's first take two variables, that is int low to point to index 0 and int high which points to the index of last element of the array, arr.length -1. Now while low is less than equal to high, okay, we calculate the middle index, that is low plus high divided by 2. We get the middle index and we check if the middle index of the array is equal to the target. If it equals to the target, then we return the middle index. And as we discussed, if it is smaller than the target, then we eliminate the left half. We do this by setting low to mid +1. Okay, and if it is greater than target, we eliminate the right half of the array, that is right will be equal to mid -1, not right will keep here high. Okay, now if we do not get any specific index, or if it is not present in our array, then we will simply return -1 as in the problem statement. In the main function here I have taken an array 1 to 9 in sorted order and the target element here is 6. Now let's run this and see. Wow, element found at index 5. 0, 1, 2, 3, 4 and 5. 6 is at index 5. Okay. Now let's see if our code successfully runs in LeetCode, because this is the fundamental thing the video is about. Let's go to LeetCode and paste our code. Now let's run this, fingers crossed. we need to change the name to nums. Okay, not a big issue. Nums. Okay, now let's submit. Wow, as you can see, our solution is successfully submitted in LeetCode and we pass all the 47 evaluation cases. All right. So you can safely use this code in your college placement exam or in company interviews. All the best. If you like this video, give it a like, share it with your friends and subscribe to my channel. Goodbye.